Hello and welcome to Mr. Boskin's Illustrative Math tutorial. This is Unit 7, Lesson 10. This lesson is representing large numbers on a number line. Our first question is, label the tick marks on the number line. Be prepared to explain your reasoning. This one is a little tricky if you just think about the numbers that you have. However, if we think about what this number actually means, 10 to the power of 7 is 10 million. There are 10 spots in here, so if this is 10 million, this is going to be 9 million, 8 million, 7 million, 6 million, 5 million, 4 million, 3 million, 2 million, 1 million. I would like us to note these in scientific notation, which means single millions are 10 to the power of 6. So this should be 1 times 10 to the power of 6. This will be 9 times 10 to the power of 6. So you should hopefully have filled this in with 1 times 10 to the power of 6, 2 times 10 to the power of 6, 3 times 10 to the power of 6, all the way through. 1 million, 2 million, 3 million, 4 million, 5 million. Okay, for our next problem, we are placing numbers on a number line. It's very important when we do these, we look at where the decimal point belongs. So our number line is up to 10 million because it is 10 to the power of 7. A is 4 million. Where does 4 million go on a number line up to 10 million? 1 million, 2 million, 3 million, 4 million. Now, the next number on here is 5 times 10 to the 6. 5 times 10 to the 6 is 5 million. Where does 5 million go? If that was 4 million, this is 5 million. Now the next one, if we look at this, this is 5 times 10 to the 5. 10 to the 6 is million. So this is 500,000, 500,000. So where's that going to go? That has to go over here. So the next one, this is also 10 to the power of 5. However, this one being 10 to the power of 5 is 75 times 10 to the power of 5. If we add 5 zeros after this, that's going to give us 7.5 million. This was 5 million, 6 million, 7 million and a half. So D goes there. Now E is 0.6 times 10 to the power of 7. So this is 0.6 times 10 to the power of 7, which is 10 million. So that's actually 6 million. So E is going to go right here. Okay, I am not going to expect you to trade number lines with a partner when we're working remotely. So let's move on to the next one, which is larger, 4 million or 75 times 10 to the power of 5. When we did that up here, that's 4 million and 7.5 million. So which number is larger? 7.5 million is definitely larger than 4 million. How many times larger? Estimate. 7.5 looks like about double 4. However, let's try to be more accurate than about double. I'll leave that to you to calculate. Okay, our next question shows a table of how fast light waves or electricity can travel through different materials. Now we're starting to really get into benefits of scientific notation. Dealing with some of these large numbers is definitely made easier by using scientific notation and using the power of exponents. The first question on here is, which is faster, light through diamond or light through ice? Diamond is 124 times 10 to the power of 6. And ice is 2.3 times 10 to the power of 8. To figure this out, we have to put things on a even playing field. Because diamond is currently set up on our table here as 10 to the power of 6. The decimal point is here. If we want to put these on a more level playing field, we can think about moving this decimal point 2 more spots so that the decimal point is in front of the 1, and then this would be 10 to the power of 8. Sorry, that 8's a little low, but that should be an exponent. Now, through diamond, the speed is 1.24 times 10 to the power of 8, and through ice, the speed is 2.3 times 10 to the power of 8. Which one of those is faster? Which one of those is bigger? 2.3 is definitely faster. Ice is definitely faster. Now, part B here says, how can you tell from the expressions for speed? Let's zoom in to highlight the values between 2 times 10 to the power of 8 and 3 times 10 to the power of 8. Okay, I have added some values to this number line to make it a little clearer. If we go from 2 times 10 to the 8 all the way to 3 times 10 to the 8, they included a nice little hint on here with those decimal points. 2.1 times 10 to the 8, 2.2 times 10 to the 8, 2.3 times 10 to the 8. So now we've zoomed in. We've labeled them. Plot a point for each speed on both number lines and label it with the corresponding material. So, if we look over here, space. Our first thing on here is 3 times 10 to the power of 8. Where does 3 times 10 to the power of 8 go? On this number line, it's right here. On our other number line, it's right there. Water, 2.25 times 10 to the power of 8. On our top number line, 2.25 is going to be about there. On our zoomed in number line, 2.25 is going to be about there. That was water. I'm just going to label these with a W. Our next is copper wire with electricity passing through it. That is 2.8 times 10 to the power of 8. So where would 2.8 go? It's very easy to see on our nice bottom number line. Put a C for copper. 2.8 on this one is about here. Put a C for copper. Diamond is 1.24 times 10 to the power of 8. Now, if we look at this, where's 1.24 is going to be about here. So diamond, 1.24 is about here. That's not going to be on our lower number line. Next is ice. Okay, our next one is ice. Ice has a speed of 2.3 times 10 to the power of 8. 2.3 times 10 to the power of 8 is easy to spot on our nice zoomed in one. It gets a little crowded on this one. Now, our next one, olive oil, is 2 times 10 to the power of 8. We'll label that one with an O. 2 times 10 to the power of 8 with an O. So now we have labeled all of those onto our graph. Label the tick marks, draw your graph, plot a point for each on both number lines. We did that. There's one speed you cannot plot on the bottom number line. We talked about that a little bit. Which one didn't fit? It's clearly this one that doesn't show up on the one zoomed in. And that is diamond. Draw the graphs on paper. Which is faster, light through ice or light through diamond? Well, let's look here. Ice, diamond. How can you tell from the number line? Faster is further to the right. Larger number, larger speed, further to the right. Okay, are you ready for more question? Don't stress out about these too much if you don't get them on your own. I will give you the solution to this. And the solution to this is 1210 or 2020. 1210 or 2020. Those are the two possible solutions. Now, we described numbers in this lesson using both powers of 10 and using standard decimal values. For example, the speed of light through ice can be written as a multiple of a power of 10, such as 2.3 times 10 to the power of 8 meters per second, or as a value, such as 230 million meters per second. Use the number line to answer questions about point A and point B. Describe point B as a multiple of a power of 10. Write your answer in scientific notation. Point B is here. If this is a number line which goes to 10 to the power of 9, that means 1 times 10 to the power of 8, 2 times 10 to the power of 8, 3 times 10 to the power of 8, 4 times 10 to the power of 8. So this is 2 times 10 to the power of 8. 2 times 10 to the power of 8. Then point A. Point A comes from this zoomed in section, which is between 1, 2, 3, 4, 5. So it's between 5 times 10 to the power of 8 and 6 times 10 to the power of 8. So this is 5.0 times 10 to the power of 8. This is 6.0 times 10 to the power of 8, which means point A would be 5.1, 5.2, 5.3. 5.3 times 10 to the power of 8. Then it asks us to describe those as a value. 2 times 10 to the power of 8 means 2, and we move the decimal point 8 spots. So 2, 1, 2, 3, 4, 5, 6, 7, 8. Comma there, 200 million. I'm not going to show you this one. Give you a little bit of a challenge to do on your own. Then our last question on this says, plot a point C that is greater than point B and less than point A. Describe it as a multiple of the power of 10 and as a value. So that means you can choose anywhere on this number line between B and A, which is approximately here. So, easy choices. Right here's 3 times 10 to the power of 8, 300 million. 4 times 10 to the 8, 400 million. Here would be 5.2 times 10 to the 8, or 520 million. Okay, this has been Illustrative Math, Unit 7, Lesson 10.